All right. But on to the reason that we all care, discrete math. Specifically, multiple quantifiers. The thing that gets me out of bed in the morning, or at least this morning, so I can make this lecture. So, let's recall what the point of quantifiers is, right? Recall that quantifiers, they allow us to make predicates into statements. They make statements out of predicates. By claiming a certain quantity of the domain makes the predicate true. That's the whole thing. So our predicates aren't statements, they have a variable, or multiple variables, right, that we need to fill in to make statements. But quantifiers say, for example, you could have for all x and d, p of x is true, or there exists x and d such that p of x is true. This claims all the domain, the entire domain, makes p of x true. This claims at least one element in domain makes p of x true, right? That's what quantifiers do. Okay, and by the way, you could theoretically define more than this, right? You could define a weird there exists quantifier, I mean like there exists two or something like that, right? Or you could be like that like all but one or something. You could define that quantifier. It's just that we found these quantifiers to be very useful, and all other quantifiers can really be made out of these. Just kind of like how and or are two operations. There's more operations, but really everything can be made out of ands and ors and stuff like that. So those are the ones we're going to focus on. They're kind of the most elemental ones. All right, so that works great for a predicate with one variable. But what about predicates with two variables? So what I mean is, for example, what if we have a predicate R of UV to equal U plays on team V. And we'll call the domain for U, we'll say that's all-star basketball players. And the domain for V, I don't know, 4 teams at random. Let's just say the Lakers, the Nuggets, the Celtics, and the Heat. A bunch of storied franchises and the Nuggets. By the way, did you guys know the Nuggets, right, came from the basketball league, the ABA, which was that rival league to the NBA that existed like the 70s. And that's the league that invented the three-point line, by the way. And then there was a merger that brought in the Nuggets. But particularly, the merger did not bring in a team that I care about. That's called the Virginia Squires, which was based in the Tidewater area of Virginia. The point is, we could have had an NBA team, but they didn't make the freaking merger. They took the money, they dropped out, So now we have to root for the frickin' Hornets or the Wizards. I hate both of them. But anyway, the point is, yes. Yeah, so we have this example. This is a predicate with two variables, right? I mean, you can have a predicate with as many variables as you want. But, I'm sleeping on John Wall stuff. John Wall. And then the next example would be, let's say, Q of A, B, where...
Professor, a quick question.
Yes.
Are we using set to do multiple qualifiers, as in like du is also, sorry, dv is also du?
No. So du is, this is the domain for the u variable. So I have two variables here, right? U plays on team V. And whenever we have a variable on a quantifier, a variable on a predicate, we have to kind of define what space that variable lives in for it to make sense. And so I'm defining our domain for U, for the players, to be the all-star players. And I'm defining the domain for the team to be these four teams. So they're different.
dv is the big picture and du is the smaller picture? As in like dv is inside du or du is inside dv?
Oh, neither. They're just different.
Okay.
They're just different, right? So these are teams and these are players. So kind of different things, right? I mean, we like I could have said, for example, X person eats Y food. And the domain for X's would be some people, like whatever domain you want it to be. And the domain for Y would be whatever domain of food you want, maybe just sandwiches.
Okay.
I'm feeling a Scooby-Doo movie today. I want to make a giant cartoon sandwich after this. Anyway. So, yeah, so QAP, and we'll define the domains for that later. But the point is, right, sometimes predicates have more than one variable. And here's the thing. If you're gonna make a statement, right, from a predicate with more than one variable, what do you need to do? For example, like if you have a predicate with one variable, to make a statement out of that, you need to quantify how much of the domain you're claiming makes the predicate true. But for two variables, what's the extra bit? I mean, we say quantity of the domain, but which domain?
Of both, I suppose.
Both. Exactly, right? It's a good color for this. This will work. To make, that's not how you spell statements. To make statements out of predicates with multiple quantifiers, with multiple variables, need to quantify how much of each domain and in what order makes the predicate true. So, predicate with one variable, I just need to quantify how much of that one domain we're claiming makes the predicate true. Two variables have to quantify how much of both the domains make the predicate true. So, for example, maybe writing it down makes sense. And so we really have, I'll use the sheet of paper, statement paper. So we really have, for two variables, we really have three options, and we have a chat. We can talk basketball after class, Safa.
Straight.
Yeah, so So there are 6 options to quantify P of X, Y with the for all and there exists quantifiers. And I should have made this sentence start over here. My bad for that centering. But the point is, they are 1, you can say there exists an X and dx such that there exists a Y and dy such that P of XY. Or you could say for all X in dx and for all Y in dy, we get that P of XY is true. Or you could say exists an X and dx such that for all Y and dy, P of XY is true. Or you could say for all Y and dy, there exists an X and dx such that P of XY is true. Or, right, so both of these, so these are kind of the homogeneous ones. Here's where we can start to mix them. And both of these have there exists X and for all Y in different orders. It's gonna matter. But also if we say for all X in dx, there exists a Y in dy, is that P of XY? Is there two chats? Exactly. Wow, that was a nice name I had. Yeah. You can chain them together in any order. I'm just listing them to, I guess for posterity's sake. It's like, I don't know, we keep all the seeds in the seed vault up in the Arctic, just in case. Yeah. So these are all we got. These are on the piece of paper because I will reference this later. Any questions on kind of where we're going with this? Like we needed to quantify both the X and the Y to figure out what things we can plug into P of X, Y, and have it be true. Okay, then we press forward. And when we press forward,